Welcome back to Must Electronics. We have built some amazing circuits together, but today we are leveling up. I'm diving into the world of Android from the raw hardware components to the apps that bring them to life. And the best part, I'm learning this right alongside you. Let's figure out how this tech really works one step at a time. Before we start exploring Android internals, let me first show you the hardware setup that we will use throughout this entire series. The main board we are using is a Raspberry Pi 4. This is a small single board computer, but it is powerful enough to run a full Android operating system. To run Android on this board, I am using a 64 GB micro SD card. This card contains the Android image that we built from source code. To flash Android image to this SD card, we need card reader. Since the Raspberry Pi can heat up during heavy workloads such as compiling software or running Android continuously, I'm also using a fan cooler to keep the board cool. For display output, Raspberry Pi 4 uses micro HDMI ports. Currently, I'm using a old monitor with a VGA port. So I'm using a micro HDMI to HDMI converter. Then I connect this to a HDMI to VGA cable so that it can connect to my monitor. As we are not using touch display, we need mouse. To power the board, I'm using a USB Type-C power cable. Now let's assemble the setup and power on the device. First, I'll assemble the fan cooler on top of Raspberry Pi. I'll connect fan cooler to the Raspberry Pi GPIO pins, that is red to GPIO 4 and black to GPIO 6. Google Raspberry Pi 4 pinout to see the pin configurations and connect accordingly. This allows the fan to run continuously and cool the board while Android is running. Next, I'll connect the display cable. Raspberry Pi 4 uses micro HDMI ports, so I connect the micro HDMI adapter. Then I connect the HDMI to VGA cable to the monitor. Now I insert the micro SD card that contains the Android image we built earlier. Finally, I connect the USB Type-C power cable to power on the Raspberry Pi. Let me also connect mouse. After powering on, Raspberry Pi boots into Android. This Android system was built completely from source using AOSP, which stands for Android Open Source Project. All Android devices, phones, TVs, cars are built on top of this same Android source code. In this series, we will explore how this Android system actually works internally. Most people think Android is just a phone operating system, but Android is actually a complete operating system built on top of the Linux kernel. In this series, we will go from absolute basics to advanced Android internals. We will build Android from source, explore Android architecture, understand boot process, learn about Zygote and system server, study binder IPC, and even create our own Android system services. Instead of only learning theory, we will perform real experiments on this Raspberry Pi running Android. To explore Android internally, we use a tool called ADB, which stands for Android Debug Bridge. ADB allows developers to communicate with the Android operating system from a computer. Let me open a terminal. I'll install ADB tool by entering sudo apt install ADB. I have already installed ADB. Before connecting to the ADB tool, we need to connect the Android device to the system. Earlier we have connected Raspberry Pi to the power adapter. I'll remove it and connect it to the system. Yeah, I have connected now. Let me see whether it's connected or not. By entering ADB devices, we'll get the list of Android devices connected to the system. Currently, one device is connected, which is the Raspberry Pi 4, where the Android device is running. Using ADB, we can inspect processes, read logs, and interact with the operating system. Now let's open a shell inside the Android system. Now we are inside the Android operating system shell. This means we are directly interacting with the Android system. We can check the operating system running on the device by entering uname-a. It's Linux, localhost 6.1, and so on. Here you might have a question. It should show as Android, right? Why it's showing as Linux? One very important thing to understand is that Android is built on top of the Linux kernel. Linux kernel handles process management, memory management, hardware drivers, and security. Android adds its own framework and services on top of the Linux kernel. Let's also check the kernel version. This confirms that Android is running on a Linux kernel. We can also check the Android processes running on the device by entering ps-a. I'm adding head here to list down only the first few processes. Like any Linux system, Android runs many processes. Each Android application runs inside its own process. Now let's look at one of the most important Android processes. Zygote is a very important process in Android. Whenever a new Android app starts, the system creates the app process by cloning the Zygote process. This allows Android apps to start very quickly. Now let's look at another important process. System server is the brain of Android. This process starts many core Android services such as Activity Manager, Package Manager, Power Manager, Window Manager. We will explore System Server in detail later in this series. Android also maintains a property system that stores system configuration and information. These properties can be accessed using the getprop command. For example, we can check the Android version by entering getprop.arvo.build.version.release. Yes, it's Android 14. This shows the Android version running on this system. Now let's understand the high-level architecture of Android. Android is structured in multiple layers. Application runs at the top layer. Below that is the application framework which provides APIs for developers. Below the framework are native libraries which provide low-level functionality. Below that is the hardware abstraction layer or HAL. HAL allows Android to interact with hardware in a standardized way. At the bottom of the stack is the Linux kernel. The kernel manages hardware resources and system security. In this series, we will explore each of these layers step by step. The Android screen, what we saw in the monitor earlier, can also be seen in the system by mirroring the screen using Screen Copy tool. Go to this GitHub page. The link is available in the description below and download this file and extract the file. After extracting the file, open a terminal here. Enter /scrcpy hyphen hyphen no hyphen audio. Why no audio is currently audio is not enabled in this. Yeah, the screen is available now here. Even the touch is also working here. In the next episode, we will explore the Android source code itself. We'll open the AOSP source tree and understand the purpose of major directories like frameworks, system, packages, hardware, and kernel. By the end of this series, you will not only understand Android internally, but you will also be able to modify and rebuild the Android operating system.